If you've ever been completely off the grid, you might know that modern iPhones have a built-in lifeline. But right now, connecting to a satellite is strictly an emergency maneuver. It's an active, physical process. You have to step outside, hold your phone up, and point it at a tiny moving dot in the sky, maintaining a perfect line of sight just to send a few bytes of data. And the software is just as locked down. This connection is a closed loop built solely for SOS messages and basic location sharing. You can't send a standard text, load a map, or refresh a weather app. High bandwidth data and third-party tools are completely blocked. Apple is shifting away from this emergency fallback model. The plan is to create an always-on network that works in the background for everyday use. But to make a continuous connection useful, Apple has to remove the restrictions on its own ecosystem and allow outside developers to access the space network. The era of treating satellites as a last resort is ending. The iPhone is being positioned as a continuous communication hub that talks to space without you even noticing. Connecting to a satellite moving 17,000 miles per hour usually fails without active pointing. Apple's 2026 hardware upgrade solves this for natural usage. Your phone locks on directly from your pocket. The technology driving this is 5G NTN, non-terrestrial networks. 5G NTN allows ground-based cellular towers to use satellites for extended, invisible coverage. It effectively turns these spacecraft into orbital cell towers that effortlessly catch your signal when ground coverage drops. This hardware automation removes the physical friction. By allowing the phone to handle the orbital tracking passively, it makes background data syncing possible anywhere on Earth. Cracking the pocket connection was the mandatory first step. Until the hardware could talk to space passively, there was no point in opening the network to app developers. To bridge the software gap, Apple is creating a new satellite API. This is the pipeline that lets third-party developers hook their apps into that passive orbital connection. To build these features, developers have to go through a highly authenticated environment, requesting specific certificates and permissions to utilize the satellite link. The first major application of this API targets messaging. Developers will move beyond basic text, allowing users to effortlessly transmit compressed photos over the new satellite link. Navigation and weather apps will follow, pulling background positioning data and delivering severe storm alerts, even miles outside cellular range. But Apple is keeping a tight grip on this pipe. Because satellite bandwidth is highly limited, they will strictly curate exactly which app features can use the connection, preventing the network from overloading with background updates. Granting developers access to this orbital infrastructure transforms satellite tech from a niche Apple feature into a foundational platform for the broader App Store. Apple's ultimate goal is to blur the boundary between terrestrial cell towers and orbiting satellites so completely that you never actually know which one you're using. Supporting that kind of invisible handoff requires massive back-end scaling. The industry is already shifting away from older, sparse networks and looking toward dense, high-capacity constellations like Starlink to handle the data load. Look at the tools on your screen. In the near future, standard software will simply continue to function, regardless of your geographic isolation. The concept of an app going offline or hitting a cellular dead zone is about to become obsolete. By combining passive, natural usage hardware with open developer APIs, Apple is turning the entire sky into a seamless extension of the cellular network.